Hi everyone, my name is Subhrajyoti and today I'll be talking to you about the WindowInsets API. If you're like me, you would have heard of the term WindowInsets quite a lot recently and wouldn't really know much about it or what it is used for. It's not something that you have to use very often, and it's only when you come across different use cases that you need to find out about it and start using it. And initially, when I started using it, I did have some hiccups in terms of getting an understanding of how it works. So this talk is about how I use window insets to actually work on a feature that I was implementing and how I use different parts of it to work out different issues. A little bit about me. I'm an Android engineer at Keep Trucking and GDE for Android. So let's get started with the talk. Okay, so first, let's find out what insets are. And to do that, let us take a look at the different types of insets that we have and see examples. And that should clarify the concept of insets for us. So the first type are the status bars. So a status bar is the top part of your phone where you see all the notification icons, your system icons, for example, Wi-Fi connectivity, as well as the clock. Then you have the navigation bars. That's the bar at the bottom of your screen that has the back, home, and recents button, and also occasionally buttons for accessibility, live captions, or even rotating your display. Then you have the caption bar. The caption bar is the bar that shows the live captions. That was a feature added pretty recently on Android. Next, you have the IME, which is the input method, which refers to your keyboard. Then you have system gestures as well. So on recent versions of Android, you have an option of hiding your navigation bar, that is hiding the back, home, and recents button, and replacing them with gestures. And when you do so, Android shows a very thin UI element at the bottom of your display that tells you the region that you can swipe from. And then you have display cutouts. We normally know display cutouts as notch. That's the thing that started with a lot of iOS devices, and then a lot of Android devices adopted it as well, because it let you expand the display and keep a very small part of it for the hardware features. So they come in different types. You can have a rectangular notch at the top. You could have a circular display cutout towards a corner of your display, for example, something that the Pixel 4 series has, the Samsung S20, etc. And this can be in different sizes. So if a manufacturer wants, they can have double display cutout, one at the top and one at the bottom. So we'll see some different types later on in the talk. Now let's take a look at an example of an app. This is the app that I was recently working on. And you can clearly see the status bar and the navigation bar here. If you look at the UI, something still seems missing. We have the map, we have some sort of a search at the bottom, but this could be improved a bit. So for inspiration, let's take a look at another app that shows a map in the majority of the display, the Google Maps app. If you take a look at the status bar, you will notice that there is no distinct status bar region here. The icons are drawn, but they're drawn on top of the app's UI. And the app's UI very nicely extends into the region that the status bar would occupy. And this looks much better. So what we're trying to do is convert the UI that we have on the left to the UI on the right, where our app's UI, or rather the map, actually extends into the status bar region. So a way to do this would be to go full screen. To go full screen, traditionally, we modify the system view visibility attribute of a certain view, and pass in a combination of flags. Here the flags we're using are the system UI flag layout stable and system UI flag layout full screen. Now you can see that the flag names are quite long and it can be very difficult to remember which flag does what. And I usually always ended up going to the documentation to see all the different types of flags and what each of them did, because it can be quite confusing to remember. And these are only just two flags. There are a combination of other flags that you can use. And even thinking of the combinations can be confusing. And that's where we usually end up on Stack Overflow. But an API 30 and above, the system view visibility attribute, as well as these two flags, are deprecated. On 30 and above, on API 30 and above, you have this new method, which you can call in the window, and it's named set decor fit system windows. And you pass in a Boolean attribute to indicate whether your window should fit the system window or not. And system window here refers to the region between the bottom of your status bar and the top of your navigation bar. And since we want to go full screen, we don't want it to be bound to that system window. We want it to extend beyond that. So we're passing out false. But not all of us are lucky to be working on apps that target API 30 plus. I'm not even sure if any of us are lucky enough to be targeting that. So there must be a compact way of doing this, which is backward compatible. And luckily there is. You can use the window compat class and call the same method. And here you pass in an instance of the window and the Boolean from the previous example. Now this this set decor fit system window method does exactly the same thing as what the XML attribute with the similar name does, fit system window. The only difference is that the XML attribute has been there for quite a while. The programmatic attributes are recent additions. Now we do have full screen, but there's an issue. Let's take a look. On the left hand, you can see the UI that we had before, that we had a contact driver button at the bottom of the screen, and it was a sticky button. So even if you scroll the bottom sheet, the contact driver button would still be visible. But after going full screen, the button kind of just disappeared. On a closer look, it's actually somehow behind the navigation bar. And since it's supposed to be sticky and not scrollable, it's not the case that you can just scroll the bottom sheet a bit more and the button will be visible. So what exactly is going on here? When we went full screen, we told our app that it can draw anywhere between the top of the status bar and the bottom of the navigation bar. And since my button had a gravity of bottom, it actually went to the bottom of the available space and ended up being drawn under the navigation bar. And this doesn't really help us in any way. You can't read the text of what the button is, and it would be very hard, even if you knew, it would be very hard to tap on that button. So this is where window insets come in. To take care of this, what we can do is find out the window inset of the navigation bar and set the bottom margin of a root view to the height of the navigation bar, so that we can ensure that the UI is always drawn above the navigation bar. So let's start fetching window insets. You start by applying a window inset listener on the root view, which gives you a lambda with the parameters of the inset instance. And you can use this instance to figure out a lot of things. So we want to get the navigation bar height. To get any sort of inset data, we have to call get insets on the insets instance that we received. And we have to pass in the type of inset that we want. In this case, we wanted the navigation bars. So we called WindowInsets.type.navigation bars. And then we also need to give the direction of the inset. Now, the direction of the inset depends upon the positioning of your inset on the display. So if it's a if it's a navigation bar, it will be at the bottom of your screen. And for that, you would have to use the bottom direction. If you're looking for the status bar, you'll be looking for the top direction. Similarly, if you had any sort of insets that to the left or right, you would be using the left or right attributes. And once you have the navigation bar height, you can change the bottom margin of the root layout and apply the navigation bar height. Now, the get insets method on the insets instance is available only on 29 API level and above. And again, we aren't that lucky. So to have an app compat version of it, or rather compat version of it, there's a WindowInsets compat class, and then you can call the WindowInsets compat, which converts the inset which is available on API 29 and above and converts it into a compat form. And using that, you can get the insets of different types that you want. And the difference here is we're using the WindowInsets compat instead of WindowInsets to get the type of the navigation bars. And again, we use the bottom direction since we're looking for navigation bar height. Now, a lot of this code, if you take a look at it, there's a lot to remember. There's a lots of methods to call. You have to remember to call the compat type of the library. You have the bottom, top, and different sides of the insets that you have to remember. There's a lot going on there. And then you would have to write a lot of code to change the padding or margin. There's a lot going on here. This is where Insetter library comes to the rescue. It's a very handy library by Chris Brains, and you can see an example of it. Exactly whatever we did earlier, we can do right now with just this much code using a builder pattern. You can call margin bottom on the builder to just specify what kind of margin you want to apply, and call WindowInsets type of method with a parameter type corresponding to the inset type you want. So if it's navigation bar, you can pass true. If it's status bar, you can pass the corresponding value as true. And all of the attributes are set to false by default. So whichever window inset type you want, you can just ask for it. And then you can apply it to the view of your choice, in which case this is the root view. Similarly, you have methods for margin, top, bottom, start, end, and also corresponding methods for padding, which saves you a lot of code. And this uses the compat version of the library internally, so you have great backward compatibility. So now our UI looks good. The contact driver button is again visible. Our map extends into the status bar. All's well. Not yet. There's still another issue left. Once we expand the bottom sheet, you can see that some parts of a UI are overlapping with the system icons or the status bar icons. The downward arrow as well as the close icons are overlapping. Even though the driver name and their ID number are visible, if you had a lot of system icons and notification icons, it would still overlap. Let's make this more tricky. Let's introduce a notch. And you can see that our UI just went for a toss. The driver's name is almost covered, like you have no clue what the name's supposed to be. And it just looks bad. And I had to take a picture here instead of a screenshot because whenever you have a display cutout, it won't show up on the screenshots. The Android framework is designed in such a way that whenever you take a screenshot, the area that's covered by the notch, it just shows up as padding and nothing is displayed there. And Again, this notch looks odd on the device. That's because it's not an actual notch that's on the device, it's just an emulated notch. We'll take a look. To emulate notches on your devices, you can go to developer options and search for the display cutout option. And this is where you can see the different kinds of cutouts that are possible, be it a corner cutout, which I mentioned for the Pixel 4 devices. Then you have the double cutout, which I was mentioning. I don't really know why there would be double cutouts, but it can be there. Punch hole could be, I'm sorry, punch hole is the one that would be on the Pixel 4 and the Galaxy devices, and not the corner cutouts. I haven't seen a corner cutout on any of the devices, but technically the framework supports it. And then you have the tall cutout as well, which is the general cutout you would be accounting for, because that's one of the most common cutouts there is. And you can choose to choose any of these, and your status bar height will change accordingly. If it's a tall cutout, your overall status bar height would increase to account for the height of the tall cutout. Now we have to add certain padding for the notch. We do the exact same thing that we did for the navigation bars with slight differences. We pass in the type of display cutout while getting the insets, and then we look for the top direction of the inset. Since the display cutout, it's towards the top here. And then we just update the padding of the toolbar direction. We just give a certain top padding to the toolbar, which is equal to the height of the notch, so that our UI is always drawn right below the status bar. Now, whatever examples you have seen isn't just the only thing the WindowInsets API can do. That was just one example where I had to implement a few things and I used the WindowInsets API, but there's much more you can do with the API. It's pretty handy. So let's take a look. Traditionally, when you had to set status bar appearance to light or dark on your apps, you would again use the decor view from the window. And as you saw earlier, again, change the system UI visibility. Here, you're combining the existing system UI visibility with another flag that corresponds to the light status bar. Again, you can see it's quite a long flag name, so you would again have to remember that. But again, if you go for dark status bar, instead of having something like a dark status bar, you invert the light status bar flag so that its corresponding value gets inverted, and then you can get dark status bar. Like we saw earlier with the full screen, the system UI visibility attribute as well as the flag is deprecated. So to do this on API 21 and above, you can use the window compat class and get a window inset controller. You have to pass in instances of the window as well as the decor view. And using this inset controller, you can do a lot of handy operations. For example, you can check if the existing appearance has a light status bar, or if you want to modify it, you can just set the attribute to false. If you want to light if you want light status bars, you can pass it to true. And you can see that it's quite intuitive. And given it's Kotlin, we don't have, again, separate getters and setters. It's just we modify the attributes directly. And we don't have to remember very long flag names. And these names are all intuitive. Showing and hiding keyboards. If you have been doing Android for a while, you would have noticed that there's no straightforward way of showing and hiding keyboards. You would have these methods specific to activities with slight modifications for fragments maybe. And then you might have some sort of a dialog fragment where your functions wouldn't work. So you would make these slight changes that you found on Stack Overflow. It would be quite confusing. WindowInsets API makes it way simpler. Here again, you get access to an inset controller by calling windowcompat.getInsetController. And then you just call the show method on the controller, with the type of inset you want. Since we want to show the keyboard inset type, we pass in window inset compat dot type dot ime on the show method. Similarly, if you wanted to hide the keyboard, just call hide on the controller with the type of inset you want. And you can already see how this cleaned up a lot of our code, and this will ensure that it works across devices. Checking for keyboard visibility. Traditionally, to check for keyboard visibility, we would have a global listener on our views, and then we would check when they change. And based on the change, we would look on the delta, and from the delta, we try figuring out the height of the keyboard. A pretty messy process. And here, if you just want to find out if the keyboard is visible, you can use the window inset compact to convert the existing insets into app compact version, and then just call is visible with the type of the inset you want. In this case, we want the keyboard inset, so we're passing IME and just checking is visible, and that's it. You can do the same thing for status bars, navigation bars, anything, because all of them are insets, and you can find out whether they're visible or not. Now there are new APIs in Android 12 added to the window inset group of APIs, which account for the new additions made in Android 12. Let's take a look at them. First, you have the rounded corners. And this is quite the common device type nowadays. You have devices where the screen is quite rounded. For example, this could be the Pixel series of devices, some Galaxy devices, Samsung Galaxy devices. I mean, there's a lot of devices out there. And if you're creating a normal app where you have a status bar completely shown, you are safe because the framework takes care of rounded corners by making your status bar height or more, or rather increasing the status bar height so that it can account for the curved edges. But like the example that I showed, if you are working on an app that goes full screen, you don't have access to a rectangular window anymore. Your window actually is rectangular, but it has corners that are actually cut out. This can be annoying when you are, for example, creating a game where there's supposed to be a button, but it's half hidden because it's cut out. Or if it's an immersive app, some icon may be hidden. To address this, a new class was added to Android View called the rounded corner. And you can call WindowInsets.getRoundedCorner with a position parameter, which corresponds to the top left, top right, bottom left, bottom right. You can pass in the position and get access to the rounded corner instance. And the rounded corner instance gives you two main properties. That is the radius of the curved edge as well as the center of the curved corner. Using these properties, you can figure out whether if you draw your UI element at the point you are going to, whether it would be cut out by the rounded corner or not. And based on that, you can apply certain margin or padding so that it is within the bounds of the curved display and it's no longer hidden to the user. And the last change that happened in the APIs was the privacy indicators. Now, that's something in Android we are quite looking forward to. Icons that are drawn on top of your app that tell you whether your phone's camera and microphone are being used. Now, these technically can be just drawn on top of your window. So if you are using full screen mode, you might have again icons on the top of your screen, and the privacy indicators can show on top of that. And on later versions of Android, you might see customizability for this, whether you want to show it in the top right or any other corners. I'm not sure if it's there already in Android 12. I haven't explored it that much, but with the kind of customization Android gives, it might be possible. Or certain OEMs might decide to give you that option. So you can account for this as well. You can call WindowInsets.get privacy indicator bounds, and this will give you access to a rect object, and the rect object will tell you the bounds of these privacy indicators. For example, the top left coordinates of the box, as well as the width and height of the container. And this is again not fixed, because in certain cases you might just have the microphone or the video icon. In some cases you can have both, so the container will be wider. Using the rect, you can find out what are the bounds of it and adjust the padding or margin of UI elements accordingly. And that's all, folks. Thanks again for coming to the talk. If you have any questions, I'd be happy to answer them now. If you have them later on, you can reach out to me on Twitter, and that's my Twitter ID. And I hope you enjoy the talk.
Thank you, Subhrajyoti, for the talk. That was really interesting to know about the insets, as we are dealing with many screens in Android environment right now for development. So
yeah, it comes in pretty handy.
So let's have the questions on the stage. First one, we would go with this. Yeah, you can read out the question and answer.
What are the backward compatible options for WindowInsets? Which API? I think this refers to which API levels. I have used it extensively for 21 and above. I didn't get a chance to work on apps that are 14 and above, so I haven't looked into that. But they work flawlessly 21 and above.
All right. Yeah. We'll take on the next question.
Why use Windows to get not work below Android R? That was the initial set of APIs that were introduced, which you couldn't use below Android R. But with the app compat set of libraries, you can get the visibility below R as well. It just took some time for the app compat version to come out. Initially, it was just introduced for Android R, but the compat version works brilliantly.
Yeah, I think that answers the question. So yeah, we are almost done with all the questions. We have one more in the chat. I'll bring that up.
Sure.
Yeah.
Translucent status bar with WindowInsets. Yes, you can do that. So how you have for WindowInsets, I for just light and dark. I mean, the light also gives you about the dark as well, the attribute. You have these different methods for setting different appearances. So what this, the attribute that I showed is light status bar that internally just sets different flags. It combines them and sets the resulting flag to the type. You can directly call the set appearance with different types of values. So there are a set in the library itself. Like you would have different, like for example, if you want them translucent or if you want some sort of a combination, you can do that as well. This was just like a shortcut method. You can actually call the underlying method with a combination of the types that you want.
Okay. We have one more over here. Yeah.
Is it reasonable to buy the display cutout setting to test for different cutouts instead of buying devices with those? Yes, definitely. I mean, if you can account, for example, the tall cutout that exists in the developer options, that actually is taller than most of the display cutouts you'd find on actual devices. So if you can account for that tall of display cutout, you're kind of accounting for shorter display cutouts as well. And it covers most of the cases. We recently released the full screen version with support for display cutouts, and we haven't had any issues on real world devices as well.
Mm.
So you can definitely use the display cutout setting.
Okay. Okay. Mm, yeah, we have one.
Just a shout out, not a shout out, a specific example here.
Mm.
If you're testing out for, I would say, display cutouts, do test out on the Pixel 4 XL device, because that has a very tall display cutout, which gives like a lot of padding on top. So that's one extra case you might have to handle.
Mm.
How could we test window insets? Uh, I am guessing this is some sort of a UI test that's been asked about. We haven't written tests for this yet, so I haven't looked into that. But I will take a look at it, and if I find something or if I'm able to come up with a solution, I'll definitely post about it.
Sure, sure. Yeah. So there's one question from Mohit here.
Do we have a Git repo, for example? I don't have one, but I can definitely publish one and share a link on Twitter with different types of things that you can do with the WindowInsets API. So if that's useful, I'll definitely publish something.
Mhm. Yeah, we have the next question.
My bottom dialog has huge margin when using insets. How do you set alignment of bottom bar when using display cutout? Okay, my bottom, I'm guessing that's a bottom sheet dialog, has huge margin when using. Okay, I think this refers to the case that we faced earlier as well, that if you're using a bottom sheet towards the top, you end up having a lot of padding. Uh, I mean, there isn't really a workout around that, because you have to account for devices that can have a large display cutout. You could experiment a bit with it. We do have some cases where we check for the actual inset height, and if it crosses beyond a certain threshold, make a few changes to the UI so that it doesn't look too odd. But that's the max we have been able to do.
Mhm. Yeah, I think we are done with all the questions. So, are you? There's one more question from Randy. So, are you sharing the slides with the?
Yeah, the slides are actually already uploaded. I'll just share a link on Twitter as well as on chat in some time.
Sure, sure. Thank you. So, yeah, I think we are done with all the questions. And thank you
Awesome.
for the talk. It was really
Thanks for
helpful.
having me at the conference.
Yeah, it was a
Bye-bye.
pleasure. Thank you. See you around.
See you.